So the next bit we're going to look at is equilibrium on slopes. So that's where we have an object on a slope at an angle, and we know that because we're in equilibrium, A is going to equal 0. So the main difference when we're dealing with object on a slope is the directions in which we resolve. Instead of resolving horizontally and vertically as we do on a flat surface, we are now going to resolve parallel to the plane and perpendicular to the plane. This doesn't matter if we're in equilibrium or there's an acceleration. Whenever we're on a slope, they're the directions we're going to resolve in. So let's jump straight in with our first example. In each of these examples, we are going to be finding the missing forces so that the particle remains in equilibrium. So here's the first diagram you've got. As you can see, we have our particle or object on a slope. We've got an angle of 30 degrees. We've got two unknown forces, P and D, and two known forces, 8 and 9. So this is a really simple example to begin with. All we're going to do is resolve in our two directions. So let's resolve parallel to the plane. And I've drawn an arrow showing which way is my positive direction. So resolving up the slope like that, I get P is in the positive direction, and then 8 is in the negative direction, so I get minus 8. Because I'm in equilibrium, that equals 0. Very simple to solve. P equals 8. Don't forget, if you're getting confused by which forces to include and which ones not to, because we're resolving in a direction parallel to the plane, if we lay our pen on perpendicular to the plane, it completely covers up those two forces, so we can ignore them. Once we've resolved parallel, we're now going to have to resolve perpendicular, as our two directions always have to be at 90 degrees to each other. So we're now going to resolve perpendicular to the plane. This gives me 9 minus D equals 0. Again, simple rearranging, that gives me D equals 9. Don't forget your units on your answers. And that's it done. So our two missing forces, P is 8 newtons, D is 9 newtons. Now, the angle didn't actually come into that question at all because all the forces were in our two perpendicular directions, which made it nice and easy. So, a slightly harder example is this one. Now, we've got our angle 30 again. We've still got two unknown forces, R and T. The difference this time is this force here is acting vertically. So the first thing we need to do is work out what the angle goes with that. Now, if we look at this as being a right angle triangle, if that's 30, we know that bit would be 60, so this bit would be 30. It's always better to stick with the angle that you know. So we know that that's 30. In this case, it would be easy to call that 60, but in other cases, if you stick with what you know, it tends to work a little better. So, we're going to resolve in our two perpendicular directions. Now this time, doesn't really make any difference, so I'm going to resolve I'll stick with what I did before, parallel first, up the slope. Now, if you stick that pen on perpendicular, all that covers up is the R. So, I've got to take account of all three other forces. Now in the positive direction I have 35. In the negative direction I have T, so minus T. I also have the component of this force acting down the slope. So I also have a minus 22 because that's rotating away from the angle, sine 30. Because I'm in equilibrium, this equals 0. So from here, all I have to do is rearrange, which will give me T equals 35 minus 22 sine 30. So T equals, you just have to use your calculator at this stage, 35 minus 22 sine 30, which equals 24 newtons. The next thing we're going to do is resolve perpendiculars to the slope. So resolve perpendicular. Again, you can use your pen. This time two of the forces get knocked out. All we have is the R and the 22. So we get R in the positive direction minus 22, and this time it's rotating through the angle. So it's 22 cos 30. Again in equilibrium, so we equal 0. Simple rearranging, R equals 22 cos 30. So R equals, use your calculator again, 22 cos 30 equals 19.1 newtons to 3 sig fig. If in doubt, always work to 3 sig fig. Now if you want the final example as well, watch the next video, or if you're happy with that one, get on with the questions.